All right, let's go over this one together. You're either done or you're stuck. So again, with this section with composite identities, kind of the priority now that kind of trumps all of the other stuff that we've been talking about when it comes to proofs is to, you got to make the angles the same, right? So over here we have a composite angle, which has more information than a single angle. So rather than try to build up the right side, let's tear down the left. So I'll draw a line. There we go. And again, do I want to use the sine over cosine or the tangent identity? Well, the right side is my target. It's already in terms of tangent. So let's go ahead and use the tangent identity. If you distribute, that's tangent of the first plus tangent of the second. Remember, you can kind of pretend like you're distributing. Ha ha, get a little chuckle. Have people go like, no way, you can't do that. And you're like, ha ha, I'm not done, right? And then it's all over 1, change the sign, so minus, and then it's the product of the top two, tangent of theta, tangent of pi fourths. All right, so now we've got at least the angles the same, right? Theta, thetas, which is what we wanted. But now we got tangent of pi fourths, which we can actually evaluate from the unit circle. That's equal to 1, right? So we get tangent of theta plus 1 over 1 minus tangent of theta. Okay, if you want to put times 1 there, you can. And if you look, is that exactly like the right side? Not quite, right? We got to commute the terms in the top. So don't stop until it looks the same. So 1 plus tangent of theta over 1 minus tangent of theta. And it's like, there you go, Ramadan. Yep, happy Ramadan. Okay, do you want to see what it looks like if we did it in terms of sine and cosine? Not really, huh? I don't blame you. You would have a complex fraction on the right, and then you'd have to multiply by cosine over cosine. It would work, but it's a little longer. So remember, the side on which you are not working is your target. So it can inform what you do. But the priority, the first new rule is get the angles the same. Okay, that's your number one rule. First rule of proofs. And again, we didn't have that before because in the fundamental identities, all of our angles were the same. But as we learn this section and in the next section, you're going to have identities for angles that are different, okay? And so using either the composite identities or in the next section, we got the double angle identities, the half angle identities, and the power reducing identities. You're going to use those to try to get your angles the same. Once you get your angles the same, then you can fall back on, some of the other things like the fundamental identities to try and get them to match. So that's your first. Too long, too short, just right? It was beautiful weather all weekend long, and now look at this, Monday morning, it's raining. Isn't that great? I mean, if it were like raining all weekend and then all of a sudden Monday morning the sun came out, I think we got a good deal. Okay, let's take a look at the next one. We're trying to prove it. Oh, by the way, remember you have a quiz tomorrow. I already mentioned that. It's going to be over. Huh? Well, we postponed it because the band was gone, and we didn't want to have that many makeups. So we moved it to Tuesday. Okay? But what we did on Friday, Kaylin, is we practiced. If you want to write that down, we practiced. We worked that, and the answer was 2 minus the square root of 3. And so that's all we did on class on Friday. I walked around. People worked with each other to make sure they could do it both with sine and cosine in terms of tangent, because that's your quiz tomorrow. Yes, Stacy.
So I have my Spanish exam tomorrow.
Okay. That trumps anything, right? That's priority number one.
Okay, do you want me to take it after school?
Whenever you can. After school or before school. Yeah, that'll work. Yep. Okay. AP exams trump all. In fact, on Wednesday, I won't see y'all on Wednesday because I'm administering the U.S. History end of course exam. So I'll have some information. Y'all will either report to this room with a different teacher, or you'll go to the library or something, or you'll, I don't know, stay home, or they'll put y'all to work painting the exterior of the building. I'm not sure. Most of y'all are taking it, right? Yeah, most of y'all are, yeah. I think everyone's taking it, right? But yeah, maybe. Okay, good. Thank you for bringing that up, Caitlin, because I was going to say we're closed. You don't mind getting paint on, but y'all be taking the test. All right. Okay, sweet. Let's take a look at this identity. We want to prove the left side equals the right side or the right side equals the left side. Peyton, did you get a haircut? Yeah, looks good. Looks good. Looks good. Um, on which side should we start if our first goal is to get the angles the same, left or right? Left. Very good. So go ahead and work on the left and see if you can get it to equal the right. I'll give you a couple minutes. You might want to start way to the left. Okay, like when you start on the left, like start right over here. Because when you use those composite identities, remember you get two terms apiece. So you're going to have four terms, and each of the terms are going to have two factors. Let's try it with the lights off. Wake up, Zach. See, it doesn't work. Well, those good breakfast tacos? Didn't work? Yeah, no, let's try it with the lights off. Mr. Kilford came in the other morning when I was doing an AP review, and he thought it was funny that I taught with the lights off. It's like, I don't know. I did it a lot with my concussion, but now that the concussion's over, it's kind of nice, right? We all study by the dim glow of our iPads, right? Because we forget to charge our iPads, so we're sitting at like 43%, and it has to last the whole day. So you dim it, right, to try and conserve energy. This is the classroom of the 21st century right here. Lights off, individual screens glowing at your workstations. And again, you're just tuning me out as you work. Focus. Intentionally distracting. How was the weather at South Padre? Good?
It was good. Like it was the first night we got there, and like the very morning of the first day we were there, it started raining. But then
Friday morning? Yeah, and then it was good?
and it was good.
Oh, nice.
Completely sunburned.
That's usually a sign of a good trip to the coast. Did y'all catch any sharks?
No,
No.
there's
But y'all got first place.
it really didn't matter.
It was just kind of a silly
It was
competition.
a silly competition. It was just an excuse.
Yeah, right. But y'all did win first
Well,
place.
there was two different bands.
Oh, okay.
Top band.
The top band got first,
Top band.
and the JV band got third. Yeah.
I don't even know. I wasn't even.
You got trophies. You got some hardware.
Big trophies.
Yeah. There's a lot of good places to eat down there.
Yeah, there was like a couple. We went on a dolphin watch, and like there was a couple of dolphin pods that we saw.
Yeah.
And then we like did an eco tour too.
Oh, nice.
We saw some like.
Did y'all go to the Turtle Rehab Center?
No, I wish.
Oh man, that's what I recommended some people to do. That's a nice place.
That would have been awesome.
And then did y'all go all the way down to the end of Seawall where that just turns into sandy dunes that overtake the roads? You didn't do that either? Oh, those are the two must-do things when you go to South Padre. There's very little traffic. It just dead ends down at the end when the island comes to an end, and all the sand overtakes the road, and the dunes are like 12 feet tall, and you just play in the sand. It's pretty cool. And then they have horse rides too. You can do horse rides on the beach. All right, let's start on the far left. You got sign of something, and the right is in terms of sign and of x and y. So using the composite identity, sign is selfless, remember, so it's sign of the first, cosine of the second. And do we keep or change the sign? S-I-G-N sign. Keep it, right? Because sign, same sign, right? Sign, same sign. So minus sign of the second, cosine of the first. Okay, cool. Now plus, we go to the next term, and we got to be careful. If that were a minus, you would need to have parentheses here, wouldn't you? Or a bracket, because you would have to distribute, bless you, the negative. But it's a plus, so we good. So that's sine of the first, cosine of the second. Sine, same sign, plus sine of the second, cosine of the first. And wow, so a lot of stuff happening there. I don't know why there's a lag, but there is. Okay, there it is. And now we got the angles the same. They're in terms of x and y, which is good. So now we look to combine like terms. Does anything good happen? I have a minus sine cosine x, and look at that, a plus sine cosine x. What happens to those? Oh! Those cancel. I know, we're so used to saying divide out now. But those cancel to give you a zero pair. And then I have a sine x cosine y, or a cosy, plus another sine x cosy. What's one of those plus another one of those? 2 sine x cosy. It is kind of cozy in here, right? It's outside raining. It's dark, a little warmer than outside. Cozy. Yeah. Does the left side equal the right side? Yeah. So now we could sign off. Cozy. And y'all are like, is that cozy? Hang on, let me try it again. Let me try it again. There we go. Cozy. Because the lowercase z looks like that, and the uppercase z looks like that. No, that's a Q, sorry. It looks just like, it's like Papa Bear. It's like Papa Bear looking over Baby Bear. That's little z and capital Z. There we go. Pretty nice. Cozy. All right. So I think that makes more sense to start on the left than the right. Again, we're tearing down angles that are bigger, composites, rather than building up smaller angles. Yeah? Okay. So we can use those new identities in a proof. Okay. Here's another identity. Prove the following identity. This is the last one of this section. Vertical line. Sound effects make everything a lot more fun, right? Like the Kentucky Derby yesterday. I was like, or Saturday, I was like, as they were coming through the mud. That was sad. Did you see what happened? Yeah, the winning horse got disqualified because, yeah. Well, it was the horse that was in the lead the entire time. What was it, like perfect defense or maximum defense or something? Maximum warfare, maximum security. Okay, obviously the best horse out in front the entire time. But when they came around, they start here and then they come around. And here on the final turn, here's where they finish. Here on the final turn, maximum security was in the lead and he was on the inside lane right here. And the crowd was all right here saying, "You go! You are the best horse! You go!" And maximum security, they're only 3-year-olds. These horses are babies. They only get to run the Kentucky Derby one time. They're only 3 years old. And because he was in the lead, when the sound blasted him, he got scared and he kind of drifted out of his lane. He came over about 2 lanes. And when he did that, War of Will had to pull up and their hooves almost got caught. It could have caused War of Will to go down, which everything behind him would have gone down. And then by the time they got here, the rider pulled him back to the inside and he crossed big time. Well, the horse that ended up winning was on the outside here, and when he drifted over 2 lanes, he had to go to the outside. And you know all about math, right? When you have a larger radius, you have a larger circumference. So you have more distance to travel. So it caused him to ruin his line, and he was saying that maybe he could have pulled it off and won, but because he was pushed out, he had more distance. So that was some math involved. But anyway, maximum security crossed big time by 2 lengths. And then this guy here, not War of Will, not the one that was behind that almost crashed, but the horse that ended up getting second place filed a complaint, and they looked at it for about 20 minutes. And sure enough, for the first time in 145 years, the horse that crossed the finish line first was disqualified. And so, Country House, I think, which was a 1 to 65 odds. It was the second. What do we call it? It was only one other horse that had worse odds has ever won the Kentucky Derby. So if you betted on a Country House, man, you won a lot of money. But there were a lot of amateur bettors that after the race was over, the unofficial results, they had a ticket for Country House. They threw it on the ground, and they threw it in the trash, and they left. And then 20 minutes later, he was crowned the winner. And so they're like, crap, I better hang on to my ticket. And they couldn't find it. I heard some stories about that this morning. But anyway, they said in any other race, if it were, any other race, it would have been an obvious disqualification. But in the Kentucky Derby, because it was such high stakes, do they want to, have situational ethics, or do they just want to stick by the rule? And so they did stick by the rule. It could have been really, really bad. I feel really bad for the horse. The guy who rode the horse, he said he grew up, riding horses for transportation in Venezuela or wherever he was from, and he came to America. And the trainer of the horse, he said it was his first win. His brother had won, and he was going to call his dad, and then they took it away from him. So I just feel bad for the horse because he's a baby, right? You're a 3-year-old. You're coming around. I mean, I don't know. it's, I don't know, racing horses, they're born and they're just like, can't I just be a horse? Why do you have to exploit me? And he comes around, he gets all scared, like, crap, what the hell is that? He's never done that before. He's never heard that before. So he loses his focus. He drifts out. The rider brings him back in. But apparently, it's not like NASCAR. You see in NASCAR all the time cars pulling out to block other cars. Have you all watched NASCAR? That's like a tactic. That is like you're supposed to do that to keep people from passing you. But in horse racing, when you do that, I guess because there's horses involved. They don't care if you do that and cars crash, right? Because it's just humans in there. But but when horses do it, it's like, when a horse goes down and breaks its leg, there's no rehabbing a horse. You know what happens, right? They kill them. So it's like, ouch. Yeah.
Yeah, you never heard that?
You don't rehab a horse with a broken leg. It's they
No,
no, they put him out. They don't put him out to pasture.
they just kill him. They put him out there.
Sleep standing.
So anyway, if you look at the replay, their hooves got caught up. Lucky nothing happened, but I really feel bad for the horse.
You didn't know that?
I feel really bad for the horse. Poor baby. Poor baby. That should be his nickname instead of maximum security. His new name should be Poor Baby.
See, I knew that they couldn't
Yeah.
lay down because of the gases in their stomach,
Yeah.
but I didn't know that they just had.
Yeah, they're euthanized. So anyway, he's not going to run the Preakness now because there's no chance at a Triple Crown. The owner of Maximum Security has filed an appeal, so we'll see how that goes. But anyway, poor baby, Maximum Security. He's a good boy. He's a good boy.
Don't they like train the horses to be aware of the noises that happen?
Yeah, they do. They do. But everybody was drunk on mint and juleps, and they were just excessively loud.
And like they have like those.
Or he was distracted by those big ass hats that he never really sees. Like, what the heck, And he went out of his lane. So anyway, I feel of all things, I feel bad for the horse. Then I feel bad for the rider. Then I feel bad for the trainer, and then I feel bad for the horse again. Okay, let's go back to here. So anyway, I'm not a big horse fan, but it was on a 2-minute race. A 2-minute race. 2 minutes and 3 seconds, I think, was the winning time for Maximum Security. It was a 5-hour television coverage. 5-hour television coverage on NBC for a 2-minute race. It was unbelievable. I didn't watch all 5 hours. I tuned in towards the very end, but wow, 5-hour NBC coverage for a 2-minute race.
What were they covering?
They talked about horses a lot. Yeah, backstories, the human element, the history of the event, and then some more about horses, and then some of the trainers and the owners. Yeah, lot 5 hours. Okay, which side do you want to start on, the left or the right? The right has more terms, right? It has more terms. And we're trying to get the angles the same. If you look on the left, we have an angle of 3u, and on the right, we have an angle of single u. So, if this were in the fundamental identity section, I would say for sure start on the right. But we have a new first rule of proofs, which is to get the angles the same. That kind of trumps all the other strategies that we've had so far. So now, if you look on the right side, even though it has more terms, I would have to try and somehow build up a single u to become a 3u. Whereas on the left, if I have a 3u, that's more information, I can maybe break it down to a single u. So with that new strategy or that new insight, on which side would you recommend starting? The left, okay? We're going to try and tear down bigger angles. Now, I need to be able to use the composite identities. So I'm going to have to write sine of 3u as the sum or difference of two other angles. Now, do I want to use 100u minus 97u? Because 100 minus 97 is equal to 3. Would that would that help me match the right side? No, that would put my angles in terms of 197. That's like, whoa, that's going way the wrong way. I'm trying to write it in terms of single u. So let's put a single u there, and then it would have to be plus what? 2u. There you go. All right, so now we use our identity, and sine is selfless, remember, so it's sine of the first, cosine of the second, sine same sign, plus sine of the second, cosine of the first. All right, are we making progress there? Yes, we are, right? We have a single U and a single U. But I still have a double U, right? Or a double V. It's really what double U is. Um, so, man, what can I do now? I need to somehow get rid of the two U's and write them in terms of single U's. Do we have a way to do that? How about using the same strategy we just used? Huh? Will that work? So the ones that have single U will leave the same, but now we're going to write that as cosine of 2U is what? 1,000 minus 998? Bless you. No, how about what? What, George? If I need to write it in terms of single U, it would be U plus U. Yeah, U plus U. Plus sine of the same thing, U plus U, times cosine of U. Man, now we get to use the identities for these two guys. And we got to be careful because remember the composite identities always generate two terms. And now we have another factor. So we better be very diligent with our parentheses or brackets. So start to the left. I'm going to have sine of U times parentheses. Cosine is selfish, so it's cosine, cosine. Cosine of the first times cosine of the second. Cosine changes signs, so minus sine U, sine U. Sine of the first, sine of the second. And again, that has to be in parentheses because we have a sine of U out front. See that? This thing here becomes this, two terms. And now we do the same thing for the other one. Plus, I'm going to bring this cosine of U to the front, cosine of U, times sine is selfless, so it's sine of the first, cosine of the second, sine saying sine, sine of the second, cosine of the first. And they're both U's, right? So it's sine U cosine U plus sine U cosine U. Now, are we making progress?
Sure.
I think so, because what are all of our angles now? They're the same. They're single U's, which is what we want, right? So let's go ahead and see if we can combine like terms or simplify this in any fashion. All right, so this first one is sine of U times cosine U times cosine of U. Those have the exact same angle, so they're the same. So what's anything times itself? It's that thing squared. So I can call it cosine squared of U. And remember, that's how we write it. We put the square between the S and the U. And this becomes minus, same thing here, sine squared of U. Now, is that Papa Pid? It looks like Papa. That's a pretty good Papa Pid imposter or impersonator. If they were both positive terms, it would be 1. If they were both negative terms, you could factor it out and it would be negative 1. But the first term is positive and the second is negative. So when they're opposite signs, it's not Papa Pid. It looks like Papa Pid, but it's not. Plus cosine of U times. Over here, I got sine of U cosine U plus sine of U cosine U. Those are the same terms. So one of those plus another one of those makes 2 of those. All right, now let's look at the right side again. Notice the left side is partially factored, especially in the first term where I have this. And the right side is completely expanded. So that's probably what we should do next, is we should distribute. So sine U times cosine squared, that's just sine U times cosine squared of U. Minus, what's sine U times sine squared of U? Sine cubed of U. So that's distributing that. And then over here, there's nothing to distribute because we don't have two terms. So if I drop the parentheses, I can actually combine the two cosine factors. So that's just going to become plus 2 times sine of U times cosine is cosine squared of U. Okay, we don't distribute into other factors. We don't do this times that times that. Okay, we don't do that. We do distribute into multiple terms, plus or minus. So these lines through there means don't do that. Okay, so now what can we do? Well, I have this plus 2 of those. Aren't those the like terms? You can have like a 1 in front of you have. if you want. I have one of those, sine u cosine squareds, plus two more of those, sine u cosine squareds, for a total of three of those. So I have three sine of u's, cosine squared of u's, minus, then I just have that lonesome sine cubed of u. And is that what the right side is?
No.
Oh, it's so close. What's the only thing I have to do? Yeah, commute the factors, right? 3 cosine squared of u, sine of u. So that's how they're listed on the right. That's the commutative property of multiplication, minus sine cubed of u. And there it is. Maximum security. We did it, yeah. So notice it looked kind of ugly, but it's simplified down pretty nicely. Now in the next section, we're going to be learning the double angle identities because they show up quite a bit. So if you ever have cosine of 2u, we're just going to start calling it cosine squared u minus sine squared of u. Okay, we're just going to memorize that that equals this. And then similarly for sine of 2u, we're going to memorize that sine of 2u, oops, I meant to highlight this. Cosine of 2u equals that. And then sine of 2u ends up being 2 sine of u cosine of u. So those are going to be the double angle identities. And they're real easy to derive just by calling 2u u plus u. They come directly from the composite identities, but they show up often enough, especially in calculus, that it's worth memorizing. Okay, so in the next section, we could probably go straight from this step to this step after we memorize those things. Okay, but we did it. We did it. Yeah, absolutely. All right, are there any questions on this section? Sweet. Okay, so I will give you all the rest of the period to work on your worksheet and or to get ready for tomorrow's quiz. It's not going to be the whole period on the quiz tomorrow. I'll probably give you 20 minutes, which should be more than enough time. And then we'll go over it and grade it. And then we're going to start the next section. And in the next section, we're going to learn double angles, which I just kind of alluded to, and then half angles. And once we get to the half angles, I'm going to introduce to you a bonus opportunity that Mrs. Lincoln's class is actually learning today because Miss Lincoln is out again. It's a bonus that Mr. Peck, Coach Peck, used to do when he was a teacher here. It's going to be worth 10 points on an exam. It's the exact value of tangent of pi 32nds. And you have to use half angle identities to get there. And it's pretty cool. It requires a lot of algebra, but that's something that you're going to work on over the course of a week, and then you'll turn it in. And if it's correct, you'll get 10 points. If it's not correct, you'll get 0 points. So we won't prorate the effort at all or nothing. Okay, but that's in the next section. So any other comments or questions before we leave this section behind? Okay, all right. So have a super rest of the period. I'll float around and answer questions.